A 100 kilogram crate is at rest on a level wooden floor. We have three questions to answer. What is the minimum horizontal force needed to start the crate moving? What is the minimum horizontal force needed to keep the crate in motion at constant speed? And what will happen if a horizontal force of 500 newtons is applied to the crate? So let's say that this square rectangle is the crate. It's 100 kilograms, and this is the floor. So for letter A, what is the minimum horizontal force needed to start the crate moving? It means that dapat ma-overcome ang static friction, diba? So that horizontal force is just equivalent to the static friction. So for letter A, Fs equals mu s Fn. But in our figure, this is the weight of the box. But since the surface is just horizontal, then the normal force is simply equal to the weight of the box or the crate. So mu s Fw, or that's mu s mg. So our coefficient of static friction can be found on the table. We have here a wooden crate on a wooden floor. So wood on wood. Wood on wood is here. So if you notice, it's a range of values, 0.25 to 0.5. So you can just choose any value there. So let's choose 0.5. So 0.5 times the mass of the crate, which is 100 kilograms, and the acceleration due to gravity is 9.81 meters per second squared. So the force needed to start the crate moving is equivalent to the static friction, which is zero point 0.5 times 100 times 9.81. That is equivalent to 490.5 newtons. And then in letter B, what is the minimum horizontal force needed to keep the crate in motion at constant speed? Meaning it's already moving, constant speed, it's not acceleration. So that force needed to keep it moving is the kinetic friction, Fk. And that's equal to mu k Fn. So still mu k Fn is just equal to the weight of the crate. So mu k mg. Mu k from the table is 0.2 times 100 kilograms times 9.81 meters per second squared. So as I said during the discussion, the force needed to keep the crate in motion will always be less than the force needed to start as an object moving. Diba? Kinahanglan ma-overcome ang static starting friction. So this is 196.2 newtons. What is this force? This is the force needed to keep the crate in motion at constant speed. And what will happen if a horizontal force of 500 newtons is applied to the crate? So if we draw this crate again for letter C, this is our crate, and then we have the floor here. So there is a force that is directed to the right, which is 500 newtons. And then there is it's already moving. We have here the Fk. So our net force is directed towards the right. So F net equals the applied force of 500 newtons minus our Fk. But then this F net is ma, so that's 500 newtons. Our Fk is 196.20 newtons. So acceleration is 500 newtons minus 196.20 newtons divided by the mass of the crate, which is 100 kilograms. So A is equal to 3.038 meters per second squared. So it means that once it's already moving, but then 500 newtons is applied, the crate will accelerate at 3.038 meters per second squared.